Okay, now we're going to get started with our second example for the chapter, which is where we try to implement something that looks a little bit like the SMPTE test pattern. Okay? But as always, we don't want to just start coding. We need to make sure we design first so that we get it right. Okay, so an SMPTE, Society of Motion Picture and Television Engineers test pattern, looks something like this, but in fact, in reality, looks like the following screen capture. As it turns out, though, that pattern, with all the different boxes that run this way, smaller boxes here, a different order and size, a series of boxes on the bottom, is maybe a little bit too complicated for our first graphical example. So instead of a full-up SMPTE test pattern, instead we're going to do something that only has the 7 basic bars across the top 2/3 of the pattern. Or, more specifically, and in a better rendering than what I can draw on the whiteboard, something that looks like this. Okay, so here we go. The first thing that we need to realize, and it's very important you understand this when you're doing your design, is that design is iterative. What that means is it's a repeated process. You do it over and over and over again. You refine your design before you start coding. Sometimes you might look at a design, a flowchart or an algorithm, pseudocode algorithm like you'll see later in the book, and maybe think that that just came naturally on the first attempt. And that's not at all how it works. Okay? So what we want to teach you is to start from a high-level design and work to a low-level design. In other words, we want to start from a high-level, less detail situation where we flesh out the major steps in the algorithm or in the design or in the system that we're working on, and then take a look at each of the pieces and add more detail as needed so that we're able to take our design and write a program from it. The concept is, or the goal is that our design eventually will be so detailed that writing the code is actually the easy part. This is where our thought goes. The coding part is more mechanical. Think first, code later. All right, so having said that, let's take a look at a high-level algorithm for the program that we're developing. Okay, before we start with our high-level algorithm, let's review really quickly how it is that we draw a rectangle in processing and the information we need to know in order to draw a rectangle. So if I imagine the rectangles that I'm going to be drawing in the test pattern sketch, they're sort of vertical, oblong, but standing on their end. And in order to draw them, I need to know 4 pieces of information. I need to know the x and y coordinates of the upper left corner of the rectangle. I need to know how wide the rectangle is in pixels, and I need to know how tall the rectangle is in pixels. Okay? Then if I'm going to draw one more rectangle to the right of that one, what's going to change? Well, it was pretty clear from the pictures and the problem description that the width of the rectangle, the next one that we're drawing, is the same as the first one. The height is also the same. As far as our coordinates go, the up and down dimension, which we're worried about because our coordinate system runs this way and this way, the y coordinate is exactly the same. So the only thing that's different for the second rectangle, other than its color, is the x coordinate. And if you think about starting here and then moving over rectangle with pixels, that means that the x coordinate there is the original x value plus the width of the rectangle. Okay? So in order to draw the next rectangle, I've got to move over by that many pixels, change the color, and everything else is the same. So that's going to make our program fairly simple once we get into the detailed stage. Okay? So just kind of keep that figure from the textbook in your mind, and we'll use that when we get into our detailed design. Okay, now let's back up. Let's take a look at our high-level algorithm for the whole problem. Okay, in our processing sketches, we're almost always going to start with a setup phase. So what we're going to do here is we're going to create what's called a flowchart. It's a series of boxes that tell us what we need to do in the program in order for it to work. Okay? So we'll start with what's called a terminator, sort of a rounded oval up at the top. That just means that's where we start. Then the arrows in the flowchart are going to tell us what to do next. Well, like I said, we're almost always going to start with some sort of a setup procedure. So I'm going to draw a box that says setup. I haven't told you what's in it yet, I haven't really thought about that yet, but that's what we're going to do first. And this is a spot where we can elaborate in a little bit. We'll expand that and make it more detailed. After we do our setup, then, what we'll do is draw all of the rectangles that are involved in the sketch. So our first rectangle is the white rectangle. So that will be a box in my flowchart algorithm that tells us where or what to do next. Okay, we're going to go ahead and draw a rectangle. And we repeat that process for each of the following ones. So we're going to draw the yellow rectangle next. All right, and we'll have 5 more of those. Normally this would be drawn in one tall column with the arrows connecting it, but since the aspect ratio is a little goofed up here, we'll just squish it over to the next column, if you will. And I'm going to cheat because I can't remember the colors. So our next one after the yellow is our cyan rectangle. We'll draw that next. Then green. Then magenta. And moving over again. After our magenta one, we have red. And then finally blue. And that is the algorithm. Okay? And so notice what my algorithm is. It's a series of steps that tell us how to do what we're trying to do, how to solve our problem. And this is a high-level algorithm because the details are missing. I don't really know what to do setup. I just know that I need to do that first. I don't know what to do specifically to draw a white rectangle. I just know that that needs to be next, followed by a yellow, cyan, green, magenta, red, and blue. Okay? So notice how the arrows in our flowchart tell us what to do and in what order, which is very important. Alrighty. So let's take and then elaborate. Let's move into a low-level design. We're going to start here. We're going to zoom in, if you will, on that setup box and examine what we need to do in order to do setup. Then we'll go ahead next, zoom in on the white rectangle box to determine what to do to draw a white rectangle. And then we'll zoom in on the yellow rectangle box to see what to do there. After that, cyan, green, magenta, red, and blue will be virtually identical to the yellow rectangle case, as we'll find out. So we won't design the rest of them explicitly since they're so much like this one. Okay? So now what you have to do is you have to imagine that we're taking setup and pinching it open, if you will, a gesture on a smartphone, and we're zooming into that to see what are the details in that box. All right, there's a series of things we need to do in order to prepare to draw our test pattern. Some of them are fairly obvious, some of them aren't. On the problem statement, it required a specific aspect ratio, width to height aspect ratio. So the first thing we should probably do then in our setup algorithm is to size the display window that's going to be shown so that we match that part of the program or the problem specification. So we'll do that first. Okay? Another thing that we want to do is not so obvious, and that is if you look very closely at the desired output, you'll see that the rectangles are solid colors. There's no outline drawn around them. So we're going to turn off the outlines so that we don't see those in our output. Now, how did I know to do that? Well, I cheat. I know about processing already, and so I know that I need to do that. So some of these things in design also require that you know a little bit about the language in order to know that you need to do something. Another way to put that is, if I forget to do this part and write the whole program and find that the output doesn't look like it should, then I have to go back and redesign and say, oh, I need to turn off my outlines first, and then I can go fix the program. Okay? Iterative, remember? We have to go back and change things very frequently. All right. Next, what we're going to do is determine the width of a rectangle. Okay? And actually, we're not going to do that. We're going to let the computer do that. The computer's good at math, so let it do the math. We need to know, based on the width of the window, how many pixels each rectangle should be wide. So that'll be a division problem that the computer can handle. So we're going to let it do that. And then lastly, what we're going to do is initialize a variable that represents the x-coordinate of each successive rectangle. Okay, remember when we were talking about drawing a series of rectangles, other than the color, the only thing that changed was the x-coordinate of those points. And so we'll start it at its first location, and then later as we draw other rectangles, we'll update that value for each successive rectangle. Okay? So there's our setup algorithm. So now you pinch in again, go back to the original design, and the next thing we were going to elaborate on was how to draw a white triangle in the problem. So let's look at that. We're elaborating then on our second part of the overall algorithm, that is, how do we draw a white rectangle? Well, this one's really simple. I've already initialized the x-coordinate. The y-coordinate is just going to be 0 because that's the top line of the screen there. So all I really need to do is I need to set the fill color. Then I'm going to use, when drawing rectangles, to white. And then I'm going to draw the white rectangle. Very simple. Okay? So after I've done setup, I'll do these steps in order to draw my white rectangle. All right. Next up then is the last elaborated piece of design, and that will be how do I draw the yellow rectangle, which is the second one. A little bit more complicated, but not much. And lastly then, for the yellow rectangle, I'm going to have to eventually set my fill color to yellow and then draw the yellow rectangle. But before I do that, remember we have a series of rectangles right next to each other, and the thing that was changing was the x-coordinate for the upper left corners of the rectangles. We started out over here at 0, 0, so I need to add a rectangle's worth of pixels to the x-coordinate to move over and draw the next rectangle. So what I'm going to do is increment my x-coordinate variable. Do that first, then change the fill color, then draw the yellow rectangle. And then for all of the other rectangles, the other 5 colored rectangles, the only thing that I would change, I would have the same exact algorithm, I would just change the color here to whatever color it is I was trying to draw. So perhaps it's the red rectangle. It would be exactly the same, okay? So we won't bother to sketch or to draw out the algorithms for all the other rectangles because all we would do is change one word. Okay? We'll assume that we get it from here and we can apply that same design to all the other rectangles. Alright, so what's next then is to implement this. Let's go ahead and type it up in processing and make it work. Alright, so here we go. Okay, we're going to go ahead and get started with our application now to draw the test pattern, which we can do since we've done our diligence with the design. And just like in our last sketch, we're going to go ahead and start out by including comments that tell us exactly what this sketch is all about. Okay, processing sketch to draw a SMPTE like test pattern, and we put who wrote it and the date that it was written. Okay? And another thing that we did as we went through the process before in our previous example was we wrote the comments for each step of the algorithm first and then filled in the code. Let's do something again like that first. So let's do the setup portion. Remember in our setup we set the size of the window. We got rid of the outlines, so we're going to turn those off, and then we determined the width of each rectangle. And the last bit in our setup piece was to initialize the value of the x coordinate. And so we'll do that here. Okay? And then we have a series of different pieces where we draw the rectangles. So we draw the right rectangle first, and then we did the yellow rectangle after that. And remember that the actual application code or the design was the same or very similar for all the other rectangles. So we'll fill those in comment-wise and code-wise as we continue. Okay, so let's talk about sizing the window then. When we create a display window in processing, we use the size method, and in parentheses we provide the number of pixels wide and the number of pixels tall we want the window to be. And so we want a 400 by 300 or a 4 by 3 aspect ratio window, and that's what that command does for us. In order to get rid of the outlines around our rectangles, we call another method called noStroke, which turns those off. And now I won't have black outlines around each of my rectangles. Okay, now let's talk about that rectangle width variable. The idea is that we want to draw 7 equally sized rectangles all the way across this window. So I could do the math myself and say I've got 400 pixels and there's 7 rectangles, so take 400 divided by 7 and that's the width of each rectangle. Right? And I could do that with a calculator or in my head and then type in the value there. But what if the width of the thing were to change? So maybe I went to 800 by 600 instead. Then I would have to remember to fix this as well. And the second thing is, computers are really good at math, so let's let it do the math. So what I'm going to do is I'm going to take the width of the screen, which is always stored in a variable named width, and divide it by 7 myself, and now, or not myself, I'm going to type that in and let the computer do the division. And now that rectangle width will be the appropriate size for a rectangle regardless of the actual size of my window. Okay, and then we need our variable x, which will start in the upper left corner, okay, 0. And then from there, we will move on by 1 rectangle width for each rectangle that we draw. Okay, now let's go ahead and see how we would execute each of these rectangles. For the white rectangle algorithm, there were 2 steps. Set the fill color first, and then actually draw the rectangle. So to change the fill color for shapes that we draw, we use a fill method call, and we provide a color in there. Remember, this is an RGB value. So right now what we're going to do is just type in the numbers that represent the color white. Okay, and how do I know that? Well, I could either use the color chooser from the processing IDE, or I could go ahead and, let's say, use Google and Google RGB for white, and I end up with 255, 255, 255. And then the last part of drawing this rectangle is to draw the actual rectangle itself, which we do with the rect method call. Remember, there's 4 pieces of information that we provide: the x coordinate and the y coordinate for the upper left corner of the rectangle. Then it's width, which is rectangle width, and the height of the rectangle, which in this case is set to be the height of the screen. Okay, now we can move on to our yellow algorithm, or yellow code based on the algorithm that we created. The first piece in the algorithm was to increment the x coordinate. So I'm going to go ahead and add 1 rectangle width worth of pixels to the x coordinate, change my fill color to yellow, and again, that's just looked up from Google or using the color chooser on processing. And then finally, another call to the rectangle method, and there we go. Now, instead of finishing out everything, let's go ahead and run it at this point and see what happens. And that looks good. I've got what I've coded so far, and it looks like a reasonable approximation of what we're trying to accomplish. I've got my white bar and my yellow bar. So what I'm doing is making sure that what I've written runs every so often, and that way I avoid what's called the Big Bang Theory. It's not a good comedy on CBS. It's not a theory of the origin of the universe. What it is trying to write the whole program first and then expecting it to run. And quite often, and almost every time, you're going to find errors. So if you write a little, run it, and then write some more, you're less likely to have errors at the end. Alright, now we said that each of the following rectangles was very similar in its code and its design to the yellow rectangle. So what we're going to do is use a little copy and paste. So my next rectangle is the cyan rectangle, and so what we have to do is just change the values. And again, this is based on a Google search. So let's try this. Very good. Looks like what we should look like. Okay, and let's repeat again. Next one is green, and so that would be 0, 255, 0. Excellent. And again, next one is magenta, which is 255, 0, 255. Perfect. Red, 255, 0, 0. And last but not least, the final color in our test pattern is blue, and so that would be 0, 0, 255. And there we go. There's how our test pattern is developed. Again, remember that we are doing the design first and then coding. All right? Well, that's it then. That's the test pattern example for this chapter.